13 participants on the call, including you. You are joining your conference as a participant. For a menu of available commands, press *#.
Talk through the city and county of Denver. And
your line is now muted.
And the recording will be sent out to all attendees. I have everyone's lines muted to reduce background noise. We will have a time for questions and discussions at the end. My name is Erica Delano, and I am a project manager for NORESCO. The Colorado Energy Office is sponsoring these City and County of Denver trainings, and to enable us to keep providing these trainings, I will be sending you a short survey at the end of the presentation. Through the survey, you'll also be able to sign up for AIA and IECC continuing education credits. So as I said before, we want to encourage questions. So throughout the presentation, please use the chat function, and I'll let our presenter know at the end. To start us off, we have Christy Collins here to provide an overview of Denver's community goals and ongoing collaboration between the Offices of Climate Action, Sustainability, and Resiliency, and Community Planning and Development. So with that, I'll let Christy take it from here.
Hi, everybody. Thanks for making time for this. And I am going to run through really quickly a bunch of slides and talk just a tiny bit on some topics, just in an effort to put into context what we're doing with the energy codes and just set up the foundation. I think my slides are not advancing. Oh, there we go. So I think it's important before jumping into any of this topic to just acknowledge the uncertainty in Denver and in the Denver development community. There are a lot of big topics that are being talked about right now, and it's easy to put sustainability and energy concerns into the back seat. I think it's also important, though, to keep in mind that central to all of our goals relative to equity and affordability our energy goals. They're sort of part and parcel to the same thing. So as we're looking at our energy goals, we're looking at Denver's long-term viability as a city and as a community, and we're looking at those bigger goals, and we're looking to respond to all of the big goals that have been brought to us by the community. Response to climate change is one of those. And so we just wanted to set that context as the foundation, because as we continue to push forward and talk about energy, it's not with a blind eye to these other considerations. It's actually with very clear vision of how this all fits together, and the fact that we don't have the luxury of relenting. We see these issues related to energy as fundamental to keeping our environment stable and healthy in Denver, and fundamental to us creating a sustainable long-term community that's viable and that provides a good life for all of our residents. So we asked ourselves the question, what is resiliency for Denver? There are a whole bunch of different things that come to mind. We could go through all of them, but I think the bottom line is that they all have a connection back to how we use energy and how we generate energy. And so we are looking through our code work to understand how we can help projects to positively contribute to what's happening, the changes that are happening in our climate and in our community, and make each one a positive contributor. So one of the big areas is through greenhouse gas emissions. We know that homes and buildings are responsible for 63% of Denver's greenhouse gas emissions, which is a lot. We also know that 40% of the buildings that are standing in 2050 will have been built between now and then. So we know that our energy codes matter a lot because our new buildings matter a lot. That's not to say that existing buildings and cleaning up the grid aren't important. Both are. The Office of Climate Action, Sustainability, and Resiliency, which I'll just call CASA for the rest of my little talk here, is doing separate things related to getting the grid cleaned up, with a hope that we'll get to 100% renewably sourced energy in Denver by 2050. But Xcel needs our help to do that on the grid. So I'm not going to talk about the existing buildings work and grid work today. Just know that it's happening alongside the new buildings work. Our goal through the work that we're doing with the codes and beyond the codes is to get our design and construction community acting together towards really having much better built outcomes where our buildings perform as we intended. And that involves getting performance considered from the very, very beginning on every project at the same time that aesthetics are considered. This isn't a new concept. This is something that the AIA floated out as a core necessary piece of our work in the architectural community a couple of years ago. We're just embracing it here in Denver. We know that we can't just pass a bunch of new codes and say, okay, here you go, community, now just make it work. We know that the market and the regulations have to move along together, and so if I gave the full-length presentation of this, you would hear me say about 200 times that we're working in conjunction with the community. I think it's important to acknowledge the CASR office here and the role that that office has played and continues to play in setting these goals and helping us to aspire towards these goals. Right now, that office is 13 people. It is slated to grow considerably. It reports directly to the mayor. That's new starting this year. They used to be a team within the Denver Department of Public Health and Environment. But because of the community's interest in climate action and the collaboration between the mayor and the community, the office has been broken out to report directly to the mayor. They set a lot of the big goals and write a lot of the big plans. So the first plan worthy of mention here is Denver's 80 by 50 plan, which was rolled out 2 years ago now, which is a commitment in Denver to decrease our greenhouse gas emissions 80% below our 2005 levels by 2050. That's a big goal. The new buildings work is part of that. So one of the milestones in that plan is for new buildings all together, not each one individually, but all together, to achieve zero net energy status by 2035. We have 5 code cycles remaining to do that. We're writing an implementation plan this year so that we can figure out how we will use those 5 code cycles to get there. We know that we will be relying heavily on amendments to the IECC and also on Denver's voluntary green code to help everybody get set up before mandatory changes are made in the code, and on the green buildings ordinance to keep raising the bar on buildings. And the whole way we'll be working in conjunction with community stakeholders to make sure that the mandatory code changes and the voluntary code changes are in alignment with what the community wants us to be doing every step of the way. In that plan, we'll be looking at energy efficiency and provision of renewable energy, but also electrification, getting off of natural gas, and grid stability. So all 4 of those are key prongs in the plan. We'll be working mostly through our energy codes, although it's important to know that CPD and the CASR office are collaborating on other codes, zoning codes. DOTI is involved with infrastructure regulations. But our focus today and in general is on the IECC and then also the Denver Green Code and the Green Buildings Ordinance, which layer in. The reason is because the big green blob represents all of our buildings that follow the mandatory base code. It's really important to have high-performing buildings that show us the way, that are individually going above and beyond voluntarily, but the bulk of the impact happens through the buildings that follow the mandatory base codes. So we have to focus on getting those codes more aggressive. The CASR office pursued funding a couple years ago, and so it's worth mentioning that funding through the American Cities Climate Challenge. 25 U.S. cities that are moving faster than some of the other cities are sharing $70 million worth of funding over the course of 2 years. And as part of that, we were fortunate enough to have the Institute for Market Transformation come out last October and help evaluate how we're doing relative to IECC compliance as it stands today in our plan reviews and our inspections, as well as our built outcomes. They've made a series of recommendations to try to help us to get to better built outcomes. At the same time, we're working on updating our codes during each of the 5 code cycles, and including the 2019 amendments to the IECC. This trajectory shows Denver's goals, and it shows that the IECC at the national level is not on track with Denver's goals. The same is true for the residential as it is for the commercial. which just means that we will have to write amendments in Denver to get our codes to keep us on our trajectory towards where we want to be. So in 2019, we used the code amendment process as a learning experience, and we got to about 15% better than the national codes, but that wasn't quite enough to even get us tracking towards our goals. And what that told us is that in future code cycles, we will have to work with the community and with our committee to figure out which amendments are the most achievable under the umbrella of a goal that we need to get to, because we know that we'll have to raise the bar 10 to 15% per code cycle to get to our goals, and we'll just have to find the right collection of amendments, not consider each amendment individually in a bubble, but consider each amendment individually in how it can fit towards getting to the goal that we have for that cycle. And it might mean that more workforce training is needed, or that there are other resources that the community needs. At the same time, we're going to be looking at the Denver Green Code. We use this as a learning experience this go around as well. We have put a bunch of things in there. On the energy side, it pushes about 10% beyond base code. And it offers two opportunities. One is for projects to voluntarily follow a higher bar and a higher standard and show leadership in the community, but the other is a preview, because the provisions that are in that Denver Green Code are most likely to be moved to mandatory base code or to be considered to be moved to mandatory base code in the next code cycle. So it gives everybody a chance to know what's coming. I'm not going to run through anything specific to IECC or our amendments, because that is what the rest of the 2 hours are about. But just to say that both the Denver Green Code and the IECC amendments that we're looking at are trying to move us towards really focusing on our built outcomes more than we are separating the built outcomes from the design and the construction processes. We want the teams to be working together towards that outcome, because really that's all that matters. So I've already talked about the Denver Green Code and the purpose to provide leadership. There are incentives. It's chapter specific. The Green Code deals with energy as well as the other aspects of sustainability that you would expect to see in a code like LEED. There are mandatory and optional provisions, prescriptive and performance, lots of choices, very achievable in Denver. 4 compliance options with a big, heavy emphasis on energy, because we know that we need to be focusing on energy. Any project that follows the Denver Green Code is automatically considered to be in compliance with the Green Buildings Ordinance. The Green Buildings Ordinance remains in place as an extra layer on top of mandatory base codes that's already raising the bar for all of our mainstream buildings, 25,000 square feet and larger. It's very achievable for all mainstream buildings, and it takes an approach of either holistic sustainability or energy efficiency as 2 big areas of focus, and then renewables and green space provided equitably throughout our city. The reason why we're so focused on outcomes is we've been seeing predicted energy use and actual energy use on buildings to be very different. Sometimes, we see buildings using 2 to 4 times as much energy as they were predicted to use. So there's a really big gap right now. That gap is not attributable to anybody's failure or any team member's failure. It just takes a really big collaborative process to close that gap. So we'll be working to help everybody close that gap so that we can support our community goals and the health and welfare of our citizens, all of our citizens. Because ultimately, we see the goal of equity, affordability, and sustainability as one goal. We can't have one without the others. So the next 3 slides just kind of show that there are a bunch of different agencies within the city and departments and a bunch of different efforts going on. We have this Zero Net Energy New Buildings implementation plan that's going to help us with our new buildings, but there are also efforts going on that expand beyond that. It's just a big effort, and we need a big effort from the community as well, and a higher level of engagement and communication and attention to metrics and accountability and holding everybody responsible. So there are a bunch of other things that are going on beyond our code work that support our code work. I'm not going to really talk about that, but just know that if there are things that are in your mind that you know are happening in other cities we're definitely looking beyond just the codes. We know that it takes kind of an elaborate network to get to high goals. We know that if we can take advantage of some of the opportunities at the planning level, that will set up our projects for success, easier success at the building level. So we're looking there as well. And we're looking at all of the aspects of sustainability in the design of our buildings, not just energy. Just that energy is the focus today and with IECC. Ultimately, though, the big focus is how do we get all of our building projects contributing positively to the future. So some of you may know, or hopefully most of you know, that Keith Fox has stepped up and is in our IECC leadership position. This is his contact information, and he's going to be leading our teams internally within CPD and also with the community, leading the conversations about IECC. So he is a tremendous resource, and I wanted to make sure everybody knows that he's there. And then I'm also here collaborating with the chapter team and collaborating with Keith on these ongoing conversations about our different goals and about our different codes that we're using. So with that, I will hand it back. Thank you.
Great. Thank you, Christy. All right, I'm going to go ahead and pass the rights over to Shauna to present. Shauna, you should have control now. We're going to jump right into the Denver amendments portion of the presentation. And again, if you have any questions, please write that in the chat throughout the presentation, and we'll answer them at the end. Our presenter today is Shauna Mozingo. Shauna is the president of the Mozingo Code Group, as well as a plans analyst and inspector. Over the past 8 years, she's provided code adoption assistance, training to code officials, builders, energy raters, and designers. She's a past president of the IECC Colorado chapter and has served on the IECC Code Development and Correlation Committees for the 2018 and 2021 code cycles. So with that, I'll let Shauna take it from here.
Awesome. Thank you so much, Erica. I just want to, just looking at the presentation and the things that we saw there, I just have to commend Denver on their process and their code. And, they have goals, and a lot of people have goals, but a lot of people don't know how to reach them. And so it's really nice to see how Denver is not just reaching out and meeting their goals, but they're also including the community, including all of the stakeholders, reaching out to see what works and what doesn't, tracking what works and what doesn't. So that's really great to see. They're not just throwing words out there, but they're actually, trying to make sure that they do work and can work. So that's, I just want to commend them. Today we're going to look at the commercial provisions. I know that it's hard to fit a lot of stuff in, especially when you're covering the envelope, mechanical, water heating, lighting, and everything under one 2-hour presentation. So we're not going to go into great detail on any one section of the code. We're going to cover a lot of the amendments. There is going to be some, of the current language in there to reference, especially as we go through mandatory requirements that inspectors would want to look for. But I would say, we could do a whole day on just the mechanical requirements in the code. And I know that Kevin Perry is coming up pretty soon with with some different things for mechanical and lighting and plan review and that sort of thing. So that's great. I hope that future webinars or future trainings, we can really hone in on some of that mechanical, because really mechanical is where the energy use is, right? I mean, just about everything in this code is geared towards making sure that mechanical equipment doesn't run very much. And so it would be good to really focus in on that a little bit more. But so we're going to go through a little bit of everything today from a inspector's perspective, hopefully. So I want to go through all the chapters, and because as an inspector, maybe you don't realize that there's some things, maybe even in the admin chapters that do affect you, or in the definitions chapter that affect you. And so I really want to just look at a couple of things. In chapter 1, there's a lot of things in there about what inspections to do and what fees to charge and stop work orders. We're familiar with Chapter 1, but there are a couple things that I just want to point out. And one of them is really because Denver has increased their code requirements and they have the higher goals, which is awesome, it also requires more detail to get put on the plans. And so in Chapter 1, there's this C103.2 about construction documents that really talks about you have to put your air barrier and air sealing details on the plans, including the location of the air barrier and what you're using, right? So what you see in the field should definitely match those details. Like look at these details from JLC and buildingscience.com. You can see what they're using and where it's going to be. So maybe, well, just maybe, it will actually be constructed that way. And so it's important to be able to look at details like this and see, okay, where's the air barrier? Where's the vapor barrier? What are they using so that we make sure we get that air sealing detail done? Because now that there's blower door requirements in commercial buildings and there's air barrier verification we're going to talk about, we really need to make sure that, yes, at plan review that it's definitely on there, but at inspection that they're doing exactly what was called on the plan. So just making sure you're comparing the plans to what's actually been being constructed in the field. Another thing in 105 is the final inspection, right? So I know inspectors know this, but sometimes we don't just have the inspectors on the webinar. So I just want to point out, it does say in the code that the building has to have a final inspection and can't be occupied until it's been approved. Some people don't realize that. And it does go in further to say that buildings or portions of the buildings can't even be considered for a final inspection. You can't call the final inspection until the code official has their preliminary commissioning report to make sure that they've got that preliminary report before you have a final inspection, because at final inspection you're going to be required to turn in your final commissioning report. So these are some things that are in the code. The final inspection has to include verification of the install and proper operation of all the building controls. So whether that's lighting or mechanical, we have to show that they are there and they work. And so just making sure that you have all that. When the final commissioning documentation, you go to a final inspection, you pick up that final commissioning report, and it comes with a checklist, but it's, letting you know what maybe some of the errors that they found and that they have been corrected, the non-compliance parts have been corrected. So that's specific, that's in Chapter 1. It's just good resource to have. It's good for builders to know that inspectors can call you on that, and it's good for inspectors to know that it's there and they can call it on that. So Chapter 2, there's some good definitions you want to become familiar with, some new ones. So, if you're a mechanical inspector, you're going to want to see that definition for direct digital control, DDCs, because it is mentioned in 403 when you get into VAV and multiple zone systems. And then I imagine it'll be the building inspector and probably the electrical inspector who will be looking at the electric vehicle requirements in the code. There's some electrical requirements for sure, but there's a lot more requirements when you get into those electric vehicle provisions that talk about parking spaces dedicated to electric vehicles in both accessible spaces and non-accessible spaces. So looking at the number of spaces, how many have to be, and we're going to go through all of this, but there are different types of spaces required. So when we get into that, it's going to be important that you know that when it talks about electric vehicle ready, electric vehicle capable, all of these things that we're going to talk about, those are defined in Chapter 2. So becoming familiar with Chapter 2 is important in this section. It's also important to know as a commercial inspector that the definition of a residential building has changed. That affects you because R2s, multifamily buildings, got taken out of the residential chapter, and so now all multifamilies, doesn't matter 3 stories or less, 4 stories or more, all multifamily buildings are commercial according to the Denver Code. So just making sure that you know that you're going to be looking at all multifamily as a commercial to these commercial requirements now. So kind of makes it easier on people to just have one set of requirements to comply with, but it is a change. And another thing to note is just go into that Chapter 2 and look at the definition for above-grade walls, because it did change to ensure that it includes between floor spandrels and the peripheral edges of the floors. So this is going to make a difference when you're looking at that insulation and you have things like, you know, 2 floors where they meet or balconies or something, you know, the whole thing is an above-grade wall, and so you have to look at that a little bit differently. It's more defined. So just check out those definitions. They definitely do apply to inspection. Not a lot changed in Chapter 3. Chapter 3 is really just about the, you know, how to install, how things have to be labeled, defaults, climate zones, and that sort of thing. We didn't have any changes in Chapter 3 for commercial, so we're going to jump into Chapter 4. Chapter 4, I want to really go through the compliance options. And I know that this seems like it's a plan review thing, but as an inspector, it is so important to know what applies to the building so that you're looking for as much as you can throughout the process of construction. Denver's added a few things that you need to be aware of, and the first is that all the commercials must comply with the solar-ready provisions of Appendix CA, and then after you get that compliance with the solar-ready provisions, then you choose a path of compliance to get them through the rest of the requirements. So it's just important to know that every building, and I didn't find a single exception in there, every building, commercial building, is going to have to comply with the solar-ready provisions first, and, you know, that applies to all buildings, and then you choose a path of compliance through there. So just wanting you to know that, because that's a change, right? And so let's look at the solar-ready provision. So the solar-ready, it's an appendix in the back of the book, and as we know, appendices are not required unless the jurisdiction specifically adopts them. And Denver definitely did a good job of letting people know that they have adopted this by making it the very first requirement in Chapter 4, right? You have to meet the CA provisions and then move forward. So it's easy to see that that's a requirement. Now, these requirements are mostly plan review verified requirements, where the designer has to show on the plans that a portion of the roof has been evaluated and designated as space for future solar, where future solar could go. Nothing has to actually go there right now, but it's being evaluated now so that it's easier to do down the road if someone wants to. Right? Of course, there are exceptions and caveats when you have some shading requirements or certain roof sizes or things. Those are always in the code, but it does have to be evaluated nonetheless. So the idea here is that we're never going to get to net zero without renewables, right? Net zero energy without some type of renewables. And so if eventually we're all going to need to put some PV or we're going to need to put some renewables on our building, later on after the building's been constructed, there's so much, it's so much harder, it's so much more costly, right, to say, oh, will the roof handle the load? Is there space? You know, do I need to redo my whole panel? Do I need to run, how am I going to run all the electric for it? I mean, like, there's a lot of things that if we could just do them up front, you don't have to put in the solar. You don't have to do everything, but we got to plan for it up front. While the building's already being evaluated for structural, let's just make sure it can hold the load of solar, right? That's a lot cheaper in the beginning when it's already being evaluated than after the fact. So that's the idea behind this, is let's just check it out ahead of time. Now, Denver does have some exceptions in there, or some additions in there, right? So in inspection, an inspection would be to see that inside the electric service panel there is a labeled and reserved space. So this is a Denver amendment here. Inspection, so there's a labeled and reserved space positioned at the end of the panel that's opposite from the panel supply conductor connection to allow installation of a 2-pole, 3-pole circuit breaker or a disconnect switch for future solar. as well as another space with a 2-pole, 3-pole circuit breaker or disconnect switch for future electric energy storage systems. So that's the Denver amendment. So those labels should read future solar electric, future energy storage, right? So we're saving that space. We've got it dedicated. And then Denver also has an amendment that will require that the interconnection pathway actually exist and not just be designed for future. So you'll need to look for that conduit or piping from the solar ready zone to the electric service panel or service hot water system. So there are some things to know there when you're doing that appendix. This shown on the screen is just the amendments. It's not the whole thing, but good to know. All buildings have to go through this. There's no exceptions to that. So, all right. So we've gotten we've gotten past this appendix. We know everything has to do that. So there's options in the code for how you comply. How do you get through compliance? And yes, that again, it seems like a plan review question, but it's not. There's some things in there that you need to know as an inspector on when people have what choices they made, so that you can verify them. It's changing, and so it's important to know that. Whenever we offer options in the code, there just becomes a lot more we need to know, and that's it. But if we didn't provide options, it would be really hard to get a building built. So we want to provide those options and flexibility so people can choose what works for them. All right, so we know we have the appendix to comply with and what you have to look for. Now let's look at those options. There's a prescriptive option. You have the option of going with ASHRAE 90.1. You have the option of going with the energy code. And within each of those, you have an option to go prescriptive or performance. And so we're going to take a little look at them. Prescriptive for this code also means things like COM checks. So making sure that if somebody does choose COM check, it's just important that inspectors and plan reviewers be kind of working together right now, and with the designers and with everybody, because yes, ComCheck is going to write a new version of ComCheck that's specific to Denver's amendments, but it takes a while to do that. And so until that happens, this code goes into effect, in July. And so until that ComCheck version comes out, we need to make sure that we're working together to see, okay, what are they doing? What are they choosing? What options are they choosing? What do I need to look at? Because I'm going to have to look at, even when ComCheck does come out, you're going to inspect from that ComCheck. Hopefully it matches the plan, but ComCheck is where some of the trades happened, or on a performance report. That's where the trades are happening. What did they trade off to do something different over here? I might have done better over here to get out of this over here, or to do less over here, or whatever. You really have to be looking at those construction documents, not just the plans, but all of the reports, to see what you need to be verifying. I've been on a lot of commercial studies, and probably, looked at 200 or 300 commercial buildings in all of these commercial studies. And one thing that I find a lot of times is that the ComCheck or the performance report or any of those things don't go out in the field on inspection. They stay in a file in the office, and that the inspector is just inspecting from a set of plans. That's fine as long as the plans match everything on those documents, but it's very rare that happens. You need to be inspecting from those documents, because that's where they are showing their energy code compliance. So just want to make sure that you guys are all looking at the same thing and you're working together, and especially on the plans, until those ComCheck and performance reports really catch up. The first optional path through the code is to comply with ASHRAE 90.1 instead of IECC. That's always been an option. However, new Denver amendments say that if you choose ASHRAE 90.1, you also have to comply with the IECC Section 4025 and 408, which is the blower doors or the air leakage and the commissioning requirements. And that's just so that because we changed the IECC and made it more restricted, we had to do some add-ons to ASHRAE 90.1 to make them equal. it just needs to, for an inspector, it just means that you need to be requiring those reports for air leakage and commissioning on top of whatever you have to see for ASHRAE 90.1. So just knowing that that's an option in there to go prescriptive. Excuse me. So it just says, you know, here's your two options. Is you have to either comply with the prescriptive, which is that first section 5, 6, 7, 8, plus those mandatory requirements, or you're going to go with, you can go performance, but Denver definitely has, you know, we've taken out the energy cost budget method, so that's not an option for you if you're going ASHRAE 90.1. You either go prescriptive or you go performance with Appendix G. Those are your two options. So what does that mean, really? If they use ASHRAE prescription, you just have to make sure that they went above the minimum in two of these areas, right? So hopefully it'll be called out on the plans which two they chose, because they have to choose two of these in order to meet to be equal to ASHRAE or to IECC. So somewhere on the plans they'll identify which options they chose, and you'll just need to verify that in the field. They have to choose two. Now, typically people would normally pick mechanical and lighting options. You know, it's not as hard to go with 75% of the lighting to be a higher efficiency or higher efficiency mechanical, but, excuse me, with the new requirements that you have to do blower door testing and air barrier verification most of the time now anyways, option one might be just as easy to choose. So it'll be interesting to see what designers do. I like how, you know, Christy touched on how things that they look, they're going to kind of keep track of what's working and what's not, and always take that into consideration when they're moving forward. And so I'd like to see this part being tracked to see, you know, what are the most popular choices? What are people choosing? Why are they not picking the other option? These are just good things to know when you move forward with new codes. So anyway, you do have an option to go with Appendix G in ASHRAE. And with that, your final performance report has to show that the performance cost index exceeds the target by at least 15%, or that your source energy index is 15% better than the source energy index in the code. So what does that mean for an inspector? It means an inspector is going to get that performance report and see what did they put in their proposed design to get this 15% extra, right? What did they trade off? What did they do extra? What did they do? And you're going to look at that inspection report, and hopefully it's also on the plans. If they said, you know, oh, we're going to do 100% of the lighting is going to be high efficacy, and we're going to do, you know, we're going to do all continuous insulation, or whatever they had to do to get to that, you're just going to want to make sure that that's what they really did. It's so key to make sure that if your plans don't have every single thing off of that performance report, then the performance report needs to go in the field, right? And so just making sure you're inspecting to that. There is an option to go prescriptive out of IECC, which also requires that you follow the mandatory items in the code. That's always been a case whenever, you know, IECC and ASHRAE both have their own mandatory requirements. And if you're going with ASHRAE for the Denver code, you do their mandatory requirements, but you also do the air leakage and commissioning out of the IECC. But when you're in the IECC, you do all of those mandatory requirements no matter what path you choose. Mandatory just means you can't trade it off. These are things you have to do no matter what. And so I know that word mandatory kind of messes people up, but it really just means that these are things that can't be traded off. So it hasn't, the path hasn't changed a lot, other than being sure that you follow Appendix CA, of course, for the Denver amendments. So we're going to look at those Denver amendments for anything, but I just want you to see what's going to be required as an inspector if somebody chooses IECC prescriptive and those mandatory also. The first part is complying with C406, the additional efficiency packages. So let's look at that first. We'll look at it in more detail later, but just knowing that you have to choose two of these packages, right? This was originally put in the code in 2012 to get more efficiency out of a building, but giving the designer and the building owner the option of how they get that efficiency. Each cycle, more options are added to the list. We started with 3, then went to 6, now we have 8. And so each cycle, a little bit more is added, but with the Denver amendments, you just have to make sure you choose 2 of the options instead of 1. This is mandatory if they go prescriptive, including ComCheck. So until that ComCheck catches up with the amendments, you'll need to be looking over the plans to see which 2 they chose and verify that they actually completed them. ComCheck has a place on it that tells you what they chose, but it only has a place for 1 of them. So you're going to have to make sure that you're looking for 2 of them until the new ComCheck comes out. With these 2 options, you could be looking at about 15 to 20% reduction in efficiency if they're not done. So we really want to be sure that we're getting these verified. Right? So there's different options. The options are the same as what's in the code. The only amendment is that you choose 2 of them instead of 1. So you could go with the 10% more efficient mechanical equipment, 10% more efficient lighting, LPDs, right, so lighting power density, or better lighting controls, a dedicated outdoor air system, which is really great. That handles your ventilation separate from using the heating and cooling equipment to do that, a better water heating design or some solar thermal, and that only applies to buildings that use a lot of hot water. Not everybody's allowed to choose that option. You could do some on-site renewables. It has to be on-site, of course. You could do a better a better air leakage, a better blower door than would already be required, or getting a ComCheck to pass by like 15% better, a total UA that is a total U factor for the whole area of the building that's better than required by the minimum code. So you just have to choose 2 of these. It's important to know as an inspector which 2 they chose, so that if they say, hey, we chose enhanced lighting controls, that you're actually looking for those enhanced lighting controls and not just regular, just the occupancy sensors or whatever that they have to do. Or if they chose high efficient equipment, that's what they're doing. If they chose a better blower door, then you're looking for a better blower door results. And so just really making sure that you're aware they have to choose 2. Somewhere on the plans it has to be identified. I'm sure Denver has amazing plan reviewers, so I'm pretty sure they're going to make sure you know what was chosen on there. Excuse me. And then so IECC has a performance option also. So C407 is the performance section of the code that tells you how you have to, the difference between the standard reference design and the proposed design and how you calculate that. But you have to do, of course, still the mandatory options, including commissioning. So you would inspect from the plans and the performance report, which should match, but sometimes, they don't, and sometimes the plan reviewers will just send the extra documents with the plans instead of making the designers put everything on the plans. Denver's pretty good. They have some energy sheets that they require, so they do a pretty great job of verifying energy. So it's just important to know what's mandatory and can't be traded off, so you're looking for that. So let's kind of walk through that because there's a lot there that's mandatory. 407 is your performance path, but everything else is your mandatory requirements. And if you look at it, you're looking at, don't forget you have to do your air leakage. That's 402. 402 is always envelope. 403 is mechanical. So look at all of those mechanical requirements. Right? And then 404 is water heating, 405 is lighting. So just, and 408 is commissioning. There's a lot there. We just kind of want to walk through that because we don't want to miss those. You're going to be needing to look at them. So for the envelope, a lot of stuff there, right? Air leakage is mandatory in any compliance path in just about any code. So we're going to dive into this a little bit later to see how it affects inspections. I just want to point out that many times when someone uses the performance path or a trade-off path, they use a third party for verification. So you want to be sure that they are looking at these mandatory items and are going to include it in their model and they're including it in their report. No matter what, you'll need those reports that we'll be talking about in a few sections. we're going to dive into every requirement on the, we're not going to dive into every requirement on the left. We're going to dive into most of the requirements on the right because those are where what's new or what's been revised in the Denver amendments. So let's we'll take a look at those in just a few minutes. Mechanical requirements, there's a lot of them. You have to think about this from an energy point of view. This whole book is just almost outside of a few of the lighting requirements. The whole book is aimed at getting that mechanical equipment to run less. And so how do we do that? We can make a really great building envelope, which will mean that the air that we do heat or cool will stay in the building more, and maybe that will cut down on some of that mechanical equipment running. But there's a lot of things that the mechanical code itself drives, and we're not going to mess with that. We're not going to mess with the mechanical code. So we are going to look at these things in the code about, the mechanical code will say, okay, here's when you have to use this piece of equipment. Here's how it has to be installed. Here's how it has to run. But the IECC is just saying, okay, great. The mechanical code requires this, and it requires that you design it to the worst case scenario. Provide all of this outside air. Provide all of this stuff. Fine. Do that design. But the energy code just wants you to say, all right, now that you've designed it to worst case scenario, we don't always live in worst case scenarios, so can we please put controls on there or control our zones or, control our efficiencies, but mostly get those controls to shut things down when we don't need them so much. We're going to listen to the IMC, but then we're going to say, okay, if there's not 100 people in the building, let's not bring in air for 100 people. Let's bring in for the 20 people that are there. Let's save some energy. And so that's what these mandatory, if you open the mechanical section of the code book, almost every single requirement in there is mandatory because it makes a difference. The hard thing is that when you open that mechanical section of the book, it's also worded the most confusing. It's very technical, and so it makes it a little bit hard to comply with. That's why I'm really hoping that in the future we can do a webinar or a class just on the mechanical requirements. Like I said, I'm a mechanical inspector and plan reviewer, as well as most of the other codes. But I've also done a lot of research studies. And so those research studies, I've gotten to take a lot of pictures and see a lot of what people are doing right and where people need some help. And so created some videos on how to do inspections on ERVs and how to do inspections for economizers and, how to open those thermostats to look at the right controls. So hopefully someday we'll get to do that. Right now we're just going to be touching because we have to cover everything. We're not going to get to every little detail of that, but let's look, if you go prescriptive or you go any path, if you go performance, these are the requirements for mechanical that you have to look at, right? So zone isolation, ventilation, efficiencies of your equipment, everything has to be looked at. There are a couple changes to ventilation, so we'll look at that in a little bit, but equipment sizing and performance hasn't changed. You still need to see that the mechanical equipment is installed, that it's installed per the plan, per the design, and it meets the equipment efficiencies noted on the plans. Either because you want to make sure, right? Because they're either just meeting the minimums or they chose higher efficiency because one of their options. So you want to verify that they're not going, below the minimums, or that they are, if they said they were going to use high efficiency as one of their options, that's really what they're doing. Either way, it needs to match the plan. A lot of time we look to see how equipment is installed, and we often verify that it works, which is great, but we're not as good as making sure that the exact size and efficiency is what's called on the plans. I've looked at, like I said, a couple hundred buildings, commercial buildings, for different studies in about 4 different states. And the one thing that I'm finding consistently is about 25 to 30% of the time the equipment installed isn't the size or efficiency that was on the plans. So I think that a lot of times things change, what you can buy or things change as you're under construction, and we're not making them go back and redo their load calcs or redo something, their comm checks or whatever, to make sure that it still passes when things change in the field. And so it's important to make sure that those match. These are just some more of the mandatory mechanical requirements that were listed at. So we're not going to, go over everything in detail, but for sure, what are you going to look for? You're going to make sure that each zone has its own thermostat, and if they do dehumidity or humidity, that they have the right control devices, right? That if they are using a heat pump and they're doing supplementary heat because the heat pump can't handle a whole load and they have supplementary heat, that there's some controls in there that say, okay, wait a minute, don't just automatically turn on that supplemental heat. Let's make sure that the heat pump can, see if it can handle it first. That there's that 5-degree temperature deadband and those different controls that are set in there so that you're not simultaneously heating and cooling, right? These requirements are in there so that the furnace doesn't kick on to the point where, it got to the temperature now that the air conditioner is going to kick on. And so they're just going back and forth. These requirements are set in there so that they can't do that, or that they're not. I know even this seems simple, like thermostats set back to 55 and 85, so that if for some reason something goes on, like you're not going to cool, you're not going to heat or cool to past a certain requirement. And it seems simple, but I mean, out of about 100, just last year, I probably opened 100 thermostats and looked at them. And it's amazing to see that those temperature setbacks are being overridden all the time. And so it seems like a given, and a lot of people are not going in and opening the thermostats, but it is true that it's not the same. It's not in there all the time. Are things programmable? Do they have their auto start? It's very common that somebody comes into a building, if the temperature is wrong in a building when a lot of people get there, we all like the temperature different. And so, if there's requirements that, when the building is closed, that the temperature is set back, but then when the building's open, that they need to be at a good temperature when you get in there. And so, so that people don't play with the thermostats and mess with things. And so are those there and are they working? Or is, Jane going to go turn up the thermostat and then John is going to go turn it down? And it's just, everybody plays with it, and pretty soon there's no efficiency to be had because it's been messed up. So it's important to verify these control requirements in there. There's a lot of efficiency to be gained right there in those requirements. So I would just challenge you to take a couple times to open some thermostats and look in them just to see. Some more mechanical. You noticed on that list there's a lot of mechanical. So economizers, fault detection, huge. It's easy to climb on a roof and see if there's an economizer on a rooftop unit. You can see it from across the roof. But do you open it to see if it's hooked up? Do you open it to see that it's got its fault detection device? Do you look to see that everyth's hooked up and that it's working? Because economizers are only good if they work. And so demand control ventilation, do you have CO2 sensors, or you have your parking garage ventilation where, you're not just bringing in a billion CFM because it's a big parking garage, but it's shut down and only bringing in, it's never going under the amount of CFM that would make it hazardous, right? There's always going to be sensors and things to make sure that it's not hazardous. But are those things being looked at? These are the things I put over here to what to look for on inspections on the things that I'm finding people are having that trouble doing. Is the efficiency, those are big old fans sometimes. What are their efficiencies, right? Do they have their controls? Do you have your automatic dampers? So there's just some things in there to make sure that you're really looking at. Those are mandatory requirements that can have a huge effect on a building. So looking at that. some things that are harder or less common to look at, I hardly ever see anybody crawling down to see what is the horsepower on the fan motor to see if it's within the limits, right, or the braking horsepower, or what was the efficiency of that fan. I've just not seen very many people willing to do that. It is a code requirement. It's a mandatory code requirement. But let's look at refrigeration equipment performances. Those are pretty important. Making sure that your coolers and your freezers are airtight. They're insulated. They have the right lighting controls, so they're not just on all the time. They shut off when somebody leaves or when customers aren't there trying to buy something, if it's those display type cases. So those are pretty important. Energy efficient users, you can imagine walk-in coolers and freezers that don't have like an airtight seal around the door or something, where you could be wasting a lot of energy. So some things to make sure you're looking at there. Excuse me. And of course, you're always going to have your duct system. Is it properly constructed? Are all the ducts sealed? That's mandatory, that all the ducts are sealed. There's still not a requirement for a lot of duct testing in the commercial section unless it's a high pressure duct, but duct sealing is still mandatory. Duct insulation, if it's outside the envelope or within the envelope, there's just different requirements, so making sure that that's met in your HVAC piping insulation. We're not talking about hot water piping, service hot water. We're talking about the piping on your mechanical equipment. Is it insulated the way that it's supposed to? Those are pretty easy things to verify on an inspection usually. And then, of course, anything outside the building. Your heating outside the building, your snow and ice melt, your freeze protection, do they have their automatic controls? It seems minimal, but just picture, for instance, a snow melt system that has this huge boiler running all the time because it didn't have a temperature sensor to say, oh, it's warm enough outside for the outside air to melt the snow, so I don't need to run. Or the pavement or whatever, the sidewalk is warm enough, I shouldn't be running. It's this boiler that's just running all the time. Huge, huge energy efficiency waster, right? So just making sure that those controls are on there. You can see that this mechanical section of the code is just a lot about controlling things and shutting them down when they're not needed. Those are really important. All of those heating outside, all those restaurants, right now especially, right, we have all these restaurants that want to be open. And so a lot of people are starting to sit outside more than inside because of the requirements now. And so maybe this time of year we're not so worried about those radiant heating systems sitting out there. But pretty soon, the temperature starts falling at night, and we get closer to the fall, and we still have people wanting to sit outside. Are those heating systems just running all the time? They need to be on some type of a timer or sensor. And so just verifying that they're there. That's not a new requirement, but we just need to look to make sure they're there. Service water heating, those requirements haven't changed, making sure that, you have your heat traps, you have your piping insulation, that you have the right efficiencies of your equipment, and that very rarely do I see the water heating supply piping requirements enforced, where you either have to do, a certain amount of volume through the pipe or a certain, a maximum distance for your piping from the fixture to the source. Very rarely do I see that enforced, but it is there. What I see is Denver has an amendment here for your water heating system that says if you have those big, huge water heating systems over 1 million BTUs, this is in the code, but there are some Denver amendments to it. If you have these big systems that have a high, that have to heat water, this is your service water heating system, not necessarily for conditioned space, but for the water heating. That if you have those big systems, they need to be high efficiency. And if you have a bunch of pieces of equipment together to equal that 1 million BTU, that you need to at least be 90% efficient. So you need to you need to think about efficiency. So that's a requirement in there that you need to be looking for. Lighting hasn't changed a ton. Really, I mean, you're always gonna have your controls. Lighting controls is huge. The lighting power densities, I mean, like the light bulbs we're using these days are kind of taking care of the lighting itself. We used to be worried about all those old light bulbs that put off so much heat they added to the load. Like now we have to cool even more because those light bulbs put off heat. That's kind of taking care of itself with the new technology, right? But and we have lower wattages that are being used and things, and that's great. That we still keep track of it so that we're not, so that we're still being diligent in that process. But where more of the lighting in the studies that I've done, where more of the lighting is being messed up is on the control, and that's the problem with inspection of lighting. Who does it, right? So is it the electrical inspector? He's, maybe he or she is looking at how things are installed and do they work and are they appropriate, but are they looking at the occupancy sensor, this room required an occupancy sensor and this one required daylight controls and, whatever, and that they work together and they're doing okay and this occupancy sensor isn't messing with daylight control. Like, is that being looked at a lot of times? A lot of times on electric plan review, you have to decide who's going to look at the energy code requirements. But on inspections, what I have inspectors tell me a lot is that, I'm an inspector. I inspect to the NEC. That energy code is not my code. And then if you go to the building inspector, they're saying, that is electric. That's lighting and all of that. That's electric, so that's not my code. And so trying to figure out who that is. And because of that, some requirements came in there for commissioning of lighting controls to at least make sure that the controls work, right, that the occupancy sensors work the way they're supposed to, that all of those controls, and we'll look at that again later on, but just making sure that they work. So as an inspector, making sure that you're getting that commissioning report that says that the functionally tested lighting controls, that the lighting controls have been functionally tested. It's very important. There's still going to be this thing about who looks to see that each room has the right controls. Who's going to look at that they're put, like this room requires an occupancy sensor, this room requires a daylight control sensor. Who looks at that? So there's still that part that has to be worked out and make sure that you have that handled, but at least somebody else is making sure that they functionally work and they're not interfering with each other so that they work the way they're supposed to. And making sure, the apartments are separately metered, and that if somebody chose digital controls as their option, that they actually put in those digital controls. So there's things that you have to look at as an inspector for that. Commissioning is a mandatory requirement in the code for all paths. So just making sure that you're looking for that preliminary report. It's supposed to be done at like a rough or final, not rough, sorry, I had that at rough, at a final mechanical inspection. And then before a final building, you get that, at final building, you get that final report and that commissioning checklist. Denver has amended the commissioning checklist, so make sure that you're getting the right commissioning checklist that's in the code in C408. So those are just some things. You're not going to be out there doing the commissioning, and there's specifics on who can do that, but you're just looking at the report. Did you get those reports and turn them in? Commissioning is huge. Commissioning, it's got so much, when you have big, huge pieces of mechanical or hot water or heating equipment, it's important that the owner is getting what they paid for, right, and that somebody is looking at all of that and making sure that it all works and noting where the settings were set on each thing to make sure that if something messes up, enough people over time mess with the controls, pretty soon it doesn't work anymore. And I've talked to commissioning agents, and they're like, if you come in after the fact and try to troubleshoot and figure out it's tens of thousands of dollars to figure out what went wrong in all that troubleshooting. But if you've got this manual that says when it worked, here's where it was set, and here's where everything was set, and here's our sequence of operation, and here's everything you need to know, then at least you can go back to that starting point where everything worked. And so it's so important to get that. It's not required on every building for mechanical equipment. Let me just specify that. For lighting controls being functionally tested, the testing of the occupancy sensors, time switches, daylight controls, those are required on every building that has them. And just about every building has occupancy sensors and time switch controls. So you're gonna need that to make sure that you're getting those commissioning reports and that mandatory checklist that is out there in C408 and that Denver has amendments to. It still includes lighting controls that you got to, check, got it checked. Somebody looked at it and made sure that they work. So making sure you're looking for that. Then I just wanted to, just a brief on ComCheck. Yes, Denver, or ComCheck PNNL has agreed to write a ComCheck to Denver's amendment. It's in the process. It takes a long time to write that. And so you will be able to see that for Denver right now. As far as I know, it's not finished. But so you're going to need to just make sure that you're looking for those two of those efficiency package options and looking for the amendments for the window U factors and things as they are now in the amendments and not what a typical ComCheck would show. You could get a ComCheck to pass right now in Denver, but it's looking at the code unamended, and so you wouldn't be able to take that pass just at face value right now until they change it. So it's really going to be important for the plan reviewers and the inspectors to work together to make it clear what's required and what's being chosen. And it's going to be important for the designers to put this stuff on the plan so that we can see which two options on 406 did you choose? What kind of lighting and windows and what did you choose out there, because the program isn't going to be caught up yet. So all right, this is something for inspectors to really look at. This is an amendment that made it into Denver's code, which is it's a good one. We see this Z-girts all the time, right? So you have these insulation on the outside of the building, and a lot of times people use these Z-girts, and so you could tell, like with all this insulation on the outside of the building is not necessarily. This is not continuous. You can't count this as continuous because look at all of that thermal bridging right there. Look at all of that metal that's on there. This is cavity insulation, and so the code calls out, all right, this is cavity insulation. You can't count this as continuous insulation. It has to be called cavity. So in your calculations, you have to calculate this as cavity insulation, unless, and there are some things in there that say, okay, if you put the insulation over or if you put the girts, the Z-girts over the top of the insulation and fastened without compressing the insulation with clips through the insulation so that you can put your exterior finish on there, then you could call this continuous insulation. Or if you can take this assembly and find a manufacturer out there that has a calculation for the whole entire assembly with it installed exactly like that, if you can go and get it tested for the whole assembly, calculated for the whole assembly to meet the U factor, then you'd be all right. It has to meet ASTM 1363, but there is the possibility that somebody out there makes just such a good insulation and a good install that you could maybe meet the U factor if you get it calced out, but you'd have to show that calculation. So if somebody's doing this, and where does this meet for inspectors? Inspectors, this just means for you, if you look at if this is what you see in the field, and you look at their plans, and their plans say that they're doing an R10 on the outside of the building, continuous insulation, you would say, you need to redo your comp check, you need to redo your calcs, because that is not continuous, right? It doesn't mean that they have to tear it down. It just means they have to redo their calcs to make sure that they pass. This is a new table for Denver for the window, for the insulation R values and the window U factors. It looks a little different than you're used to, mostly because Denver took out all the other climate zones. You know, you're only in climate zone 5, so it's nice that just that one is in there. But it does look a little different for the window U factors, and so let's look at it. There's some U factors for fixed and operable that you're used to seeing, and those U factors haven't changed. What changed is the fact that those U factors for fixed and operable only apply for vertical curtain wall, storefront, and site-built fenestrations that are type AW products. I know this says, I think that says A, but it really should be B, because AW products is a B footnote. So what that's just saying is that those type, if you are going to use AW products, which we'll talk about in a second, they have to meet this standard and be classified as AW. Then you can use that. Otherwise, all other fenestration 0.30, whether it's fixed or operable, because it doesn't have a fixed or operable, all other is 0.30. So unless it's an AW product, it has to be 0.30. Your entrance door is 0.77. That's not a change. And then your solar heat gains, not a change there. Still how it, and your skylights all still in there. Where I see inspectors, what I'll point out is the projection factor on your windows. We'll talk about that in just a second. But let's look at those AW products. So the performance class rating should be regarded as an indication of the level of performance, right? So the least stringent requirements are for the R performance class, and the most stringent are for the AW performance class. So that's the kind that we're requiring, the most stringent. So R is usually 1 and 2 family dwellings. They have a class LC that's used for low-rise and mid-rise multifamily dwellings and other buildings where you have a higher loading requirement. CW is used for low-rise and mid-rise where you have high loading requirements, but you have some limits on deflection and some heavy use. And then AW is used for high-rise and mid-rise most commonly to meet the increased loading requirements and limits on deflection, and in buildings where frequent and extreme use of fenestration product is expected. So you have these buildings that use a lot of glass, they need to be high-performing glass, right? Because there's no, you have to make sure that you're using really good glass, because there's a metal frame involved, and there's a lot of this product usually on the building. So that's where we're just saying if you're using fixed or operable fenestration as your vertical curtain wall, storefront, and site built, it has to be it's a type AW product, and it's 0.38 or 0.45. Everything else is 0.30. Excuse me. Inspectors, you know, it seems like projection factor, that's a plan review item, but I would just say, well, yes, it is a plan review item, but it's also for you. So if they say, oh, we're going to meet 0.30 window because we have a projection, solar, it's just about solar heat gain coefficient, sorry. So I'm going to meet a 0.40 solar heat gain coefficient. I might have had to have, well, let's look at the table. If I need to be on my south, east, and west, I need a 0.38 if I don't have a projection. I can be a 0.46 if I have a projection, or I can be 0.61 if I have a really big projection. So we go back here and we look at this projection. And so they say they put in a worse window because they have this big projection, and you go out there and there's no projection. Sorry. You need to put in a better window. That doesn't mean we're going to automatically make them yank out their window. It means that now you need to redo your calcs, redo your comp check, redo your performance report, and make sure you still pass. But you didn't put in as good of a window as you could because you said there was a projection and there isn't one. That's all. I would just say make sure that windows have a huge impact. Solar heat gain coefficient has a huge impact on the size of equipment that goes in there, right? How much heat is making it in this window? the air conditioner is going to have to offset that. So the windows are hugely important, and in commercial buildings we use a ton of windows. I would say in a climate zone 5, it's as important, if not a little bit more, than the U factor. So making sure that if they say, oh, we're going to put in a worse solar heat gain because we have a projection, that they really do have a projection. So I just want to point that out. All right, let's talk about the envelope. Denver's really putting a lot of thought into this. It's great. The 2021 is going to have a lot of this in there too, so you're going to be a step ahead. But Denver's doing a lot better even than the 2021 for the most part. So let's look at this. There's been some thought, and I love that this is in there because a lot of people got a parking garage, and they have sprinkler pipes running through that parking garage, and they're trying to figure out, how do I keep those sprinkler pipes from freezing? And so I see all kinds of things. You know, people say, well, I'm going to heat that. I'm going to build a plenum and heat it. Oh, you have a heated space. Guess what? Now you have to meet the envelope provisions, right? Now you have to do insulation and air barriers. Oh, but I don't want to do that. I want to have a drop ceiling so that I can access those sprinkler pipes. Yeah, well, you can't put insulation on a drop ceiling without an air barrier, and you can't, like if you just met the code, it's almost impossible to do. And so Denver has looked at that and said, wait a minute, is there a reasonable way to handle this issue? And I think that they came up with one, and I really like it. So it's just saying, if you're going to heat this space right here between the drop ceiling and the garage so that your sprinkler pipes don't freeze, that's fine. Do so. And so see that air barrier that's there, the blue line is your air barrier that would be required because you put heat in there, and you would be required to have your R30 insulation or whatever your value is. They're just saying, okay, you don't have to put that air barrier down. You can do this. You can heat this space and get your insulation values, but you need to put a minimum of R5 on the floor of that plenum and a total of R19 in the floor. And if you do that, you can do away with the air barrier. We're not going to make you put that air barrier down. Pretty much that layer of that R5 insulation on the plenum floor is going to serve as your air barrier pretty much. So the slab has to have an R-flat. Oh, wait. The slab has to have a minimum R-flat. Sorry, I put that in the wrong place. I had it right until this morning. At 5 o'clock this morning, I changed it, thinking I read it wrong. The slab has to have R5 and the plenum floor has an R19. Man, I had that right this morning. So you'd put an R5 right up here. You put an R19 down here, and then you don't have to have that air barrier. Sorry, I totally messed that up. I had it right at 5 this morning, and I second-guessed myself. All right. I shouldn't read code at 5 in the morning. That's what that teaches me. All right, so air barrier compliance options. You still have, if you're an I occupancy, you still have the option of doing that material option, assembly option, or actually testing it. And if you are anything else, then you're going to do air barrier verification. So let's look at what that means. If I'm group I still have this option of, making sure that the materials that I choose are sealed and continuous, right? So all of these different materials that are in the code you can still use. They're deemed to comply as long as they're sealed. Just making sure that that, if you choose plywood, it's 3/8 inch, but are you sealing that plywood, right? Are you sealing it up and making sure that you are sealing everything? Otherwise, that's not an air barrier. But you still have this option, but only group I occupancies. Or you could do the assembly and materials components. So if I have an assembly, concrete itself is permeable, so I need to have some coating or some plaster or stucco. I have to have something on there, but the total assembly is now airtight, so I still have that option. The problem is when you get into buildings, it's really hard to see where your air barrier is going to be continuous. I get these, buildings, and it's hard to verify where is my, my roofing membrane on the top going to meet and be continuous with whatever I'm doing in the wall, and what am I doing in the wall, and how am I going to get a continuous air barrier in some of these locations, right? It can't be an afterthought. So making sure that you're getting those. A lot of people use spray foam as an air barrier, which you can. That's totally fine. It's just that, remember, to be an air sealant, if you look back in the code section, it says I can use open cell as an air sealer, but I have to have 4.5 inches of it just to be the air sealer. I can have 1.5 inches if it's closed cell foam. So just making sure that you're looking for those products. It can't be an afterthought. You know, you've got to get air barriers where they need to go before you start doing all this after framing, and it's too hard to get up there. Things like this are, you know, we can't have this situation where how am I going to get that air barrier up there? This insulation isn't going to do its job without its air barrier. And so making sure that you get that done. And as an inspector, there's some good resources out there, and designers, there's some good resources out there with just go to all of the insulation and air barrier manufacturers' websites. They give you, you know, here's all the different things we've tried, and here's what we found works and doesn't work. You know, you can say, oh, we tried fluid-applied Tyvek on Texas A&M. Here's the challenges. Here's the solutions that we found. Utilize the resources. A great resource as an inspector that I've had to use is Air Barrier Association of America. You click on air barrier. It gives you every manufacturer of air barriers out there, and it gives you all of their install instructions and specifications. So that's an awesome resource out there. But air barriers are still hard and not being verified. So Denver has come up with these requirements that you do look at your air barriers and continuous. They have to be continuous, and somebody needs to verify them, right? So it says that the installation of a continuous air barrier has to be verified by a registered design professional or approved agency. You review the construction documents and the supporting data to make sure that they've called it out and they've put those details on there. Inspection of the air barrier and assemblies have to be conducted during construction while it's still accessible for inspection, and so you can verify that any repairs have been made that have needed to be made, and then that final commissioning report has to be completed, and this is the building commission, the air barrier commissioning report, right? That has to be done by that registered design professional or approved agency and provided to the building to you by final inspection. So the report has to identify deficiencies found during the review of construction documents and inspections and details of corrected measures used. And then there's an exception in there. 10% of the air barrier doesn't have to be verified as long as, you know, the building leakage test is appropriate. 0.4 CFM per square foot of air leakage has been met in accordance with the next section. But if you don't have to test, there are some buildings that don't have to test. So if you don't have to test, you have to do full air barrier verification. So just knowing that is new to Denver is this verify your air barrier. It's that important. So building thermal envelope does have to be tested in accordance with ASTM E779. There's some lenience here, like if you're over 0.4, it doesn't mean you automatically fail, like you know, okay, go redo everything. It means that you're going to need to do a smoke trace or infrared or something, find out where the leaks are, see if there's any measures that can be taken to fix it, and then provide a new report saying what you identified and what you fixed. Yes, this says, okay, well, maybe I don't have to meet 0.4 CFM then. Yeah, well, you're going to have to go through a lot more time and testing and stuff, and it would be more worth it to pay attention to the details up front. The idea is that you pay attention to the details up front, then you don't have to go through these extra measures. At some point, you won't have this leniency, so this is like a step. So I would just say that it's better to pay attention to all the air sealing up front. That's why there's verification on that air barrier, right? Somebody go make sure you put it in right, because you've got this blower door test that you're going to have to do now on commercial buildings. So you don't have to test the entire building envelope where the following are tested. So this is just saying you don't have to test the whole building, You do have to test anything under a roof. So if you have a multi-story building, that top floor definitely has to be tested. Or if you're one story, the whole floor, or, you know, you have mixed levels. Anything that has a roof over it, anything that has an entrance or a loading dock, or if you're below grade, those have to be tested. And then everything else is, you know, kind of a representation, an area-weighted average of at least 25% of the wall that encloses conditioned space. So just know that that's in there. Rooms with fuel-burning appliances. This hasn't changed a lot. It's just saying that if you have the Denver amendment, right now the code changed to just be if you have fuel-burning appliances and you bring in combustion air, you need to separate them from the rest of the building, and it's just talking about the appliances that use to heat and cool the building, and Denver said plus water heating. Right? So if water heating, do you like that? Yeah, that's nice. Water heating, space conditioning, and water heating. So if you bring in combustion air, put that inside of a room and thermally isolate it so that you're not dumping that air into the rest of the building, or put in high-efficient equipment that is direct vent and the air comes out, goes into the equipment, and is exhausted directly out. No air changes place with the room. So that has been in the code for a long time. The difference is Denver added water heating equipment. Now, really, we're going to talk about, when we get into mechanical, we're just talking about this, a few things that Denver has changed. It's just really looking at the control of the flow of the outdoor air. So if you think about, like I said earlier, the energy implications of all the air brought into the building, the mechanical heating and cooling has to make up for that, right? So my research has shown that commercial buildings, one of the highest contributors to energy costs is the amount of outside air that we're bringing in and the equipment that has to offset it. Doesn't mean we don't bring in air. It just means that we, you know, turn it down and that we don't need as much, or we control it. You know, if I have to bring in 5,000 CFM of outside air at the temperature that it is outside, my air conditioner is going to have to offset that, right? So why not? We're going to design, again, according to the mechanical code, but we're going to control that air. So it's just saying when you have these equipment, this, you know, whether it's a DOAS or, you know, a VAV or energy recovery, whatever, your makeup air unit, you're going to have to put some type of equipment on there to control that's designed to provide fault on excessive outside air and display or report to the DDC, maintain, measure flow rate. So it's just making sure that we are looking at that control air. So that's specific to Denver, something to pay attention. The energy recovery ventilation systems is important. There is an amendment for Denver on this. So we've always required if you bring in a lot of outside air, you need to put it through this energy recovery ventilator so that it's, you know, it kind of feels like it's tempering. It runs that hot air across the heat exchanger, pulls the heat out, so you're bringing in cooler air, or vice versa in the winter. Energy recovery also deals with some humidification issues, but it usually it only applies to fans over a high rate. But Denver amended it to also say that the exhaust, if you have exhaust that exceeds 3 times the value, so whether you're bringing air in or taking air out, it will apply. And so those are some things that you're going to need to look at. I usually put a video in right now of how to inspect those energy recovery ventilation requirements, but we're not going to have time to do that. So just making sure that you are familiar with this requirement for Denver on ERVs. And then fans, if you have a low capacity ventilation fan that's used for your mechanical ventilation, doesn't mean every single fan out there. It means the fans used for ventilation, this is the efficacy of them, right? So if you're using a bathroom fan as part of your ventilation system, it needs, here's the efficacies required HRV inline fans. So that's in there. And then I am really proud at Denver and the marijuana grow facility folks that really worked together to come up with a lot of the requirements that made it into Denver's code, whether it were for mechanical or lighting, because they really went through a lot to get some requirements in there. And so there's just some new requirements for indoor agriculture operations. Doesn't mean it has to be for those grow facilities, but that's what we're putting it in there. So it's any indoor agriculture operation. Your efficiency of your cooling equipment has to meet the right efficiencies. If you use dehumidification, which most of them do, then you have a separate freestanding dehumidification system, chilled water system for heat recovery, and then it's just asking that you really deal with the dehumidification system that can use a lot of energy and making sure that you're taking all of that into consideration. You will use dehumidification, so making sure that it's efficient and appropriate. Lighting didn't change a lot. Lighting for dwelling units there's a requirement that not less than 90% of the permanently installed fixtures are high efficacy, and the definition of efficacy did change, so pay attention to that. It's 65 lumens per watt. And then lighting for refrigerated applications, that didn't change. It's always been buried kind of in that mechanical section. So Denver put it in the lighting section too, so that you know that it's actually there. That if you have lighting installed for walk-in coolers and freezers, that it's that you have to have the right lighting controls and the efficiencies. And then exterior lighting controls provide controls that shut the lights off when there's no daylight, or when there is daylight, or reduce it by at least 30% from midnight to 6, or an hour after close of business to an hour before opening, or 15 minutes of non-activity, or put a time switch control. Somehow control the lights so they're not on when they don't need to be. And there is an exception, like if I come out of this dark parking garage and I go into, I don't want a bunch of bright light, and so there is some exceptions for lighting required for adaptation. And then parking garage lighting controls, just making sure you have this big, huge parking garage and look at all the lights on. Do they need to be on all the time? Or if they do, we want to get security. We're never going to interfere with security, ever. The code won't let us. It makes sure that there are provisions in there that we can never interfere with security. That's great, but and egress. But does it have to be on full blast? Can we shut it down? Can we shut some of them off and leave some of them on? We just want to make sure that we've put some thought into this, right? That you have a lighting zone that's no more than 3,600 square feet, so that you're controlling the lights in a smaller section at a time and not for the whole thing, and that they have controls that shut them down when you don't need them. And during the day it can be still really dark inside the parking garage. Great, turn those lights on when they're needed. But next to any of these openings, you don't need lights on because you got daylight coming in. It's just making sure that there's some thought. How do you do this on inspection? Who's going to do this? Is this the building inspector or the electrical inspector? So we've got to figure that out and look for those controls. But just know that the lighting controls still have to be functionally tested. All right, lighting power hasn't changed a lot. You still have the two methods. They can go a building area and space method. I don't get into this too much with the inspectors. It just says, building area method, what kind of building are you? Here's how many watts per square foot you are. Just know the plan reviewers jump through a lot to make sure that every building has the right amount of lighting. And same with here, if you're doing space by space, it breaks each space out to say, okay, here's how many watts per square feet each type of space is required. So they're going through a lot at plan review. And it's going to ask you that on inspection, you're looking to see, okay, they said they were going to do this much. Are you going to be out there counting every light bulb? Hardly think so. But we need to at least make sure that they're falling in, I see a lot of inspectors that will, do random and then kind of weight average it, not count every light bulb, but look in a room. Are they pretty close? In a couple rooms, I can assume they're pretty good, right? But if they're really off, then maybe I need to look at something differently. I need to look at it more closely. And who is that? Lighting for plant growth, again, such great work with the industry out there on this to come up with these rules about lighting. So if you have non-LED lighting, you have these electronic ballasts, right? And that you are using, your lighting is in line with national recognized standards, and that you have some pretty high efficacy lighting, and it's a different, it's not a watts per square foot. We're talking about moles here. It's a different lighting for plant growth. It relies on different type of lighting, and still making sure that type of lighting is efficient. So great work with the industry to get these requirements in there. You have to have your LEDs. You have to meet the right standards. And it does say, you need, if other lamps and luminaires not previously mentioned must have third-party verification showing that they meet the right standards. So just making sure that we're really being, that's a lot of light. Those grow facilities, those indoor agriculture, they use a lot of light to grow their plants. And the code has always had plant growth lighting amended out. We want to get some of that efficiency, but we have to do it in a way that won't hurt the industry. So all of that was taken into consideration. Great job on behalf of all the parties there to get that in there. I'm hoping that we can take that to the national level. Electric vehicles, this is in the code. It's in the 2021 also. It was being appealed, but it's not going to come out, I don't believe. So as of call Friday, I don't think it's coming out. So it's going to be in there, and Denver's going to have it. Almost every jurisdiction that I help do code adoption wants EVs. They want it in their sustainability programs, and they want it in their code somehow. So they're all taking either Denver's language or the national language and putting it in their code, even if they're going to skip the 2021. So I find that encouraging, and I applaud Denver for leading the way on some of this here in Colorado. So you're going to have EV charging there for new construction and level 3 alterations. So making sure you know what those level 3 alterations are. It's a defined term. So making sure that you have EVs. It's there's a lot of definitions, remember, in there about that. So there are group R occupancies, your R1s, your R2s that are all commercial, R3s, R4s, R3s and R4s over 3 stories, and then all your group R1 and R2 have this requirement that, our group R occupancies with 3 or more dwelling units shall be provided with, or sleeping units shall be provided with EV charging in accordance with the table, and so we'll look at that table. I show you this because as an inspector, first knowing there's EV charging, electric vehicle supply equipment, electric vehicle ready, electric vehicle capable. These are all defined terms, so making sure you know what we're talking about by going to that Chapter 2. Calculate the number of spaces that you need, and this EV isn't on top of that. It's included in it, but it has to be included with the right number of spaces. And so who's going to verify that? That's, is that going to be the planning and zoning department who sets how many parking spaces you have to have, and they're going to look at it, or is it the building inspector, the electrical inspector, or maybe a mix of everybody out there to verify this? Typically, the building inspector isn't out there counting parking spaces, but maybe you're not going to have to count parking spaces. You're just going to have to make sure that they have their appropriate amount that's in there. But so you had the group R. Now you have the group A. So A, B, E, I, M, and S2. So that would say that, okay, well, if I'm an F or an H or any other S or whatever, maybe this doesn't apply to me. So provide electric vehicle charging in accordance with the table. Again, we'll look at that, calculate your number to the nearest number. So if you come up with needing 3.4 spaces, you need 4. All EV supply equipment installed, EV ready, capable. Calculate the number of spaces as provided by the Denver Code, the planning and zoning. I just put this on there. This is Southwest Energy Efficiency Project, SWEEP. has this great thing on their website. I just want to show it so you can go to their website and see. But they say, you know, okay, we're going to look at the numbers required for Denver, but here's what other people are doing for EV capable in Aspen, Georgia, Boulder, California. They do a great job of showing what other people are doing. How many of them are doing just capable? How many of them are doing, you know, EV ready and installed? So it's nice to see what other people are doing. So I just put that up there to say, you know, go to, I call it SWENERGY, but it's southwestenergy.org. That's a lot of us are familiar with. All right, circuit breaker. So identification, when you're doing this EV ready, you know, circuit breakers or circuit breaker spaces reserved for EV capable spaces, EV ready spaces, and installed spaces have to be clearly identified on the panel board. Conduit has to be identified at both the panel board and the termination point, and there are some exceptions for 1 and 2 family dwellings in there. So it's also letting you know that you have to take into consideration accessible parking, right? So you can't put all of the EV ready outside of accessible and or inside accessible. If you're only required one, where are you going to put it? If I put it in the accessible parking spot, then nobody else has access to it because they're not allowed to park there. If I put it outside, then the accessible people that have accessible won't be able to, and so you have to really consider this. It says to put in at least one accessible parking space has to be EV ready. So you might, even if you are only required to have one, you might end up having to have 2. Or I have seen diagrams where they put it right in the middle, but I don't know that that would be acceptable. So some things to think about. EV spaces in Group R occupancies. This is the table that says, okay, if I have one parking space, I need one, has to be EV ready. I don't have to do capable and installed. I have to have it EV ready. 2 to 9, I need a 1, and then 20%. If I have 10 or more spaces, 15% of them have to be ready. Everything else, 5% have to be installed, and then the rest has to be capable. So just knowing that you have this requirement in there, and this is for your other occupancy. So just knowing that's in there. Then we go to 406, just reminding you. We're out of lighting and we're into 406. This is that additional efficiency package options. You have to choose 2, right? So reduce, you can, if you choose reduce lighting power density, the lighting power calculator is 10% more efficiency than if it was just done to 405. Yours is 30%. Because the lighting, you know, the lighting in the code hasn't caught up with the technology. So going 10% doesn't mean anything. So in Denver, the requirement is 30% more efficient for that. So just making sure that you know that, that requirement is in there. And then if you're a tenant space, which one do you choose? So Denver has identified that if I'm a tenant space, there's certain ones that I can't choose, but I could choose a more efficient mechanical equipment, more efficient lighting, more efficient digital lighting, dedicated outdoor air, or reduced reduced hot water system. It's not. It is not giving you the envelope allowances because the envelope is already done by the time a tenant space, right? It does allow you to do renewables as long as the entire building complies and not just that tenant space. So just looking at tenant spaces in C406 and how that works. And then 408, just remembering on those commissioning, I just want to reiterate that lighting controls have to be commissioned. We do have, we do have a opportunity in the future to do just a webinar on commissioning. And in fact, when we get to additional resources here pretty soon, we're going to see that you have access to any webinar we've ever created. And so I know there are some out there on mechanical and on commissioning, so making sure that you know that those are out there. But it's really important, commissioning, but also it's definitely for mechanical and service water heating, but I think a lot of people forget that commissioning is required for lighting controls. And it's so important because we still don't know who's going to look at all of that or whose job it is to do it. And so, and I just want the designers on this, in this training to know we are going to be looking at that lighting. It's a requirement in the code even outside of Denver. So that's not new to Denver. But what is new is that Denver has an exception that just says, lighting systems are exempt from functional testing requirements in buildings where installed lighting load is less than 20 kW, you like that extra W, and the area work is less than 10,000 square feet. So that is for Denver only, right? So just making sure that you know that. I saved that for the last because I would rather everybody think about, I need all of this stuff tested, and I need to make sure everything works together, whether I'm 10,000 square feet and less or more, but then it show you towards the end that it really only applies to certain buildings. And here's Denver's checklist. This is, in 408, they have a checklist in the code. Denver has modified it a little bit just to get more specific for Denver, but lighting controls is on there. Water heating controls, economizer controls, HVAC controls, everything is on there. Do I have my preliminary report? Do I have my final report? So making sure that you're getting this checklist. The nice thing about the checklist is that it's one thing in the mix of all these commercial buildings that have totally different paths of compliance, totally different codes they're using, and even if they use the same compliance path, nobody turns in the same kind of documentation. It's nice to have just one thing out of the whole project for every project that will be the same. I know how to read this report because it's the same report I read for every single project. And so it's nice to have one thing, I think, in the inspection process that's easier to do. I know that was a lot. I know that was a lot to go through, and we didn't dive into anything excessively. It's really hard to do when you have to do a whole code in 2 hours. And so I brought up the things that I find the most in commercial buildings, doing research studies, what things make the most difference. Again, just totally applauding Denver's efforts. It doesn't matter if you agree or disagree with what they put in there. The process they use to get everybody's input and opening it up to the public and continuing this process all the time of just wanting everybody's input and wanting to do what's right for everybody is just amazing. I will tell you right now, not very many jurisdictions do that. And so huge kudos to Denver for that in putting together something that meets people's needs, meets the environment's needs, and is actually putting it in language that's understandable and doable. So good job, Denver. That's all I have. If there's some questions or anything, Erica?
Great. Thanks, Shauna. We do have some questions. I just want to highlight this slide to start. We created a code adoption toolkit that's available on the Colorado Energy Office's website. And we're also developing the troubleshooting guide that covers code interpretation issues, definitions, passive compliance, and code conflicts. So definitely check those out when you have a chance. But we do have a few questions for you already, Shauna, and everyone can feel free to either unmute themselves if you'd like to participate in the discussion or write in the chat a question that you have. So the first question is, why was group I, believe that's a one, or I, excluded from the whole building air tightness testing requirement?
That's a great question. Group I, because it's, Group I encompasses a lot of different things. It's just a unique occupancy where sometimes you can't do the things that you want to those buildings, either for security reasons or for health reasons, that there are just some things you can't do to those buildings. And so it was just one of those that was left out this time. And I don't know. I'm trying to remember if in the 2021 group I ended up being left out also. I can't remember right off the top of my head. But it's usually because of that kind of occupancy. It's more about a health-related issues. And so we still need to give them some certain options, but you know, if we find that they're able to meet the requirements over time too without being a health risk, then we can include Group I down the road.
Sounds good. Thank you. Another question for you, Shauna. Is there a list of approved agencies for air barrier verification?
That's a great question. I'm not sure if Denver has one or if they're going to monitor one. Right now, the code just says, you know, registered design professional. So could it be the architect or the engineer? I think we're going to have to, maybe if Keith is online, he might be able to answer that for Denver. Some jurisdictions will maintain a list, and other people just are like, we don't have time to maintain a list. I'm not sure what Denver is going to do.
This is Keith. And right now, we do not have a list. What we are going to do is have a policy of who can perform the commissioning on the air barrier. Some of the people that we're going to include with some experience in that will be the architect, the engineers, other certified commissioning agents that have performed this type of inspections and verifications. So.
Perfect. Thank you.
Great. Thanks, Keith. Here's another question. What happens if the designated solar roof or panel space is taken during a TI or improvement?
Yeah, that's going to be the challenge, right? Because I can set on the plans, here's the roof area required to, or that we saved for roof panels, and that is solar ready. And then I go to split up the building later on down the road or modify the building later on down the road. Who's going to remember that that was there or where it was? Will the building department remember it? Are those plans available? It's not, you know, that's going to be tricky to follow no matter what. That's going to be as tricky to follow as whether, you know, there's a lot of things. We want to do core and shells and then future tenant finishes. That's just the easy way to do things instead of making you do it all at once. But when we do that, especially in the energy code, it's so hard to track things, right? Okay, I'm going to let you out of some of your mechanical requirements because we're not going to know what mechanical equipment you really need until you put a tenant in that space, or your lighting, or sometimes people let people out of the skylight requirements or the this or the that, and thinking, okay, at tenant finish, we'll catch it. Well, do you? And so it's really hard when you deal with tenant spaces, and future code additions are going to really crack down on policies and procedures for tenant spaces. But it's, I don't know. That's going to be maybe a policy part for Denver or something on how to keep track of that solar ready zone.
And can I just piggyback on that? Denver does have a policy that tenant finishes are required to align with the original IECC compliance for the building. So if a prescriptive path was taken, then the tenant finishes need to stay in line with that prescriptive path. If a performance path was taken and assumptions were made on behalf of the tenant space, then the tenant space needs to either adhere to those assumptions that were made, or there needs to be an update made to the full building compliance that's shown. So we do have a policy in place that addresses that, and we are working on the details of how we are tracking our tenant finish permit submittals to ensure that they get tied back to our core and shell, but that is a requirement in Denver.
That's awesome.
And the submitting teams need to be conscious of that requirement. That's
awesome. I wish every jurisdiction would do that because it is really a missed opportunity out there. I've had designers tell me, that they, even if they know what their tenants are going to be, they're going to design as a core and shell and then tenant finishes, because most of the time you have different plan reviewers that do tenant finish versus core and shell, and they don't communicate a lot of times. And so it is a strategy to get out of requirements by doing a core and shell where they don't where they let you out of certain things until tenant finish. When you go to tenant finish, you say, oh, no, we don't have to do that because it was already done, and hope people don't catch it. I've had designers tell me that's their strategy. So kudos to Denver for having a policy already in place.
We do.
Thank you, Christy.
To enforce, definitely. So I will admit that it's a hard thing for us to enforce, but it's definitely a policy, and it's definitely a goal, because we want our building outcomes performing.
Awesome.
Great. All right, I have one more question for you. Can one coat the bottom side of the slab with sealer for a drop ceiling plenum to meet air barrier requirements instead of doing the R5 and R19 combo that Denver came up with?
Well, I mean, yeah, Denver, that's just an option in there. So it says you're allowed to do that. If you want to build that plenum to meet code, they're going to let you, but they just know that not very many people can or will do that. And so if you can, I mean, well, let's just say, let me just say, coat it, meaning in order for it to be an air barrier, it has to be continuous and it has to be sealed. So coating the top of a panel doesn't make it an air barrier. If you had a drop ceiling, for instance, just coating the top of the panel with an air barrier type material doesn't make it a continuous air barrier. You'd have to seal all those joints and seams of that drop ceiling, that's not why you have a drop ceiling there, right? So just realizing that if you do a drop ceiling, it's really hard to do an air barrier and still be able to use the drop ceiling for what it's for. But if you can show that you can put a continuous air barrier in there and build that plenum to code, they're not going to make you do this other option. This was just an allowance.
Great, thanks for that clarification. Those are all the questions that I have for you right now. Shauna and I will stay on the line for another couple of minutes if any other questions do come up, but if not, keep an eye out for my follow-up email with a survey in it to sign up for continuing education credits and a link to this recording as well. But otherwise, thank you everyone for attending, and thank you Shauna and Christy for your presentations today.
Sure.
All right, Shauna, I'm going to go ahead and end the presentation now.